So now we're on our very last part for the modeling, and then we can get onto the assembly. This time we're going to model this clip here. So let's have a look at the part in more detail. If we look at the shape, we can see it's basically a bar that's been bent into shape. To model this, it looks like it's going to be a bit tricky. If we look at the profiles from the front, we can't see that we can model the whole object from the front because we have this curvature that goes along here. If we look from the top, we can't see that we can model it from the top either, because if we look at the profiles, we're looking at the planes and how many points lie on that plane. So we've just sketched out the planes upon this. We can see how that sits flat on that plane at these points here. But we can't sketch upon that plane because this is curved. This curves upwards. So sketch this as one object, it's not possible. Let's take that away and look at a different profile, say from the XZ plane. So if we laid this plane, and what I'll do is just offset this from the center. And this is exactly the same as what we were doing if we were sketching. So let's move it this way. So we start to see the object appear on that plane. You can see that, well, it curves this way. So we can't create that profile. Or can we? If we break this down into the individual parts, rather than think of this as a whole object, then it starts to become clear. I've actually set the view modes of this object, so you can see we've got a flat line view for this panel and a simple shaded view for this object. When I start to hover over the different sections, you can see what's happening. So this is actually sectioned out, and through this we can pick out parts of this object and build it out with 2 or more sketches on different planes. Let me just move this plane. So we're just going to transform this and move this up. So we are now on that plane with this part going along here. Hit OK. So that can actually be a sketch upon this plane, and then we look to this side, and then we have to deal with the top view. We can't deal with it directly from the top, so we need to create a sketch for the part of this. Now if we look and bring this around so it's slightly diagonal, we can see if we draw a line here, a straight line down, this is on that plane. So we can sketch this part and this part as 2 sketches, join them together in 3D space and create this object. If we look at the technical drawing, we can see the shape that we need. It's just a sketch. And because the profile of this object, so we're looking at the cross section of this bar, is just basically a circle, we use a sweep workflow to create a circle profile and sweep it along this path. So what we've got to do is look at both the shape of the object and also the cross section of the object to understand how to model that in 3D space. So we're modeling this part here and this part that comes around here, and we just need to rotate this so it points this way and connects that tangent with our other sketch. This will become clear in the demonstration. Let's start modeling this part. If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a coffee site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. Any money that's kindly donated will be used to expand the channel. For this demonstration, we're using the part design again. I've already created a new document and saved it as part 4. We can come up to the view and toggle the axis cross so we can see the center of our scene. Looking at the technical drawing for reference, we're going to use this part for our first sketch. We've got some dimensions in here, so if you had the real object in front of you, you would just be measuring those up. So we've got 20 millimeters along this edge and a radius of 3mm. So remember, we need to break this down into its primitives or match the geometry to our sketch tools. We've got sketch geometry here, which are just lines and arcs. Or if we think about this, this is basically a rectangle with rounded corners. Back in the part design, we can create a new body and create our first sketch. And I'm going to place this along the XY plane because we're looking down on the object and we want to create this rounded rectangle shape. The good thing is that we have that in our sketcher, rounded rectangle, or we could just use a line with arcs. Get ourselves centered and put our first geometry down on the page. Before we go anywhere, we need to add some constraints because we're not sure we're at the right size yet. So I'm going to add some radius constraints to this one. If we look at the constraints of this object, we can see we've got a quality constraint here. So 13 goes across all of these arcs. And we've got 15 down here as well. But remember, we only need part of this object. So I want this radius here and this line and this one here. So I'm going to remove this geometry here. To do that, we can use the box selection. So a box select here, it selects these edges and these points within that selection. It didn't select this part here because the whole of that edge wasn't inside the box selection. There is another way of selecting, and that's from the bottom up. So from right to left. And you can see that whatever that bounding box touches will be removed. So we've got two ways of selecting. So let's take all of those edges that bounding box touches and hit delete. Now we're left with this here. You notice the constraints have disappeared for this curve because we had the constraints going across both. So they were link constraints. Let's take both of these curves, both of these arcs, and set a radius of 3mm. Now we can set up this length. So this length was 20mm. So this arc going around here is where the connection is going to be. So the connection is going to be going this way. So this needs to be tangent with this line to make this smooth transition because it doesn't come out this way. If we look, we can see it's got a smooth transition. So this curve here will be this side, just curves outwards and connects up to this part. To do that, let's take these points and keep them in line. So taking all four of those points and using a vertical constraint. Let's keep this symmetrical. So by taking this point and the center point and using the symmetry, and now we're fully constrained. Let's close that and see what we have. So we have this shape here. So now we've got our first sketch. We need to create the other side. So this side here. For that, we're just going to add these arcs to start with, but we're not going to add them to the same sketch because we're going to need to rotate it in this direction. So if we take this part, you can see it's rotated 45 degrees up this way. This part is rotated 45 degrees up this way as well. So they got both different rotation points. So we need to create a separate sketch. To do that, let's come back into the part design and create a new sketch along the XY plane, and OK. We can see our other sketches in here. So let's create our arcs. We're going to be using this axis here because we need to rotate it, so we need the center of rotation in the middle. Endpoint and rim point arc, and we're going to create the reverse of this. So we want them coming around this way and connecting up like so. But remember that this needs to be on this line here. So we're just going to use this line for reference, visual reference. Let's make the radius of those 3mm. And we need to keep these two in line. Horizontal constraint. And let's bring them this round to here somewhere. And we need to keep these two in line with horizontal constraint. and these two in line, horizontal constraint. We're going to do the same with these points, keep them vertical. So all those are in line, so we can move those now. And we need to position these properly. So we know the distance between these two is going to be 20 millimeters. So it's the same distance here. And now we can attach these 2 points to this line. So this point and this point get attached to this line. Let's do a point on line constraint, but we've got the horizontal constraint, so we don't have to worry about it. Now we can take these 2 points and the center point and keep them constrained symmetrically. So we've got these 2 arcs. It may look a bit weird because we've got the other curve underneath there, but this will all come apparent in a moment. So we have that sketch. It sits there. Looking back, we can see we've got 17 millimeters between this point and this point. So let's add that to our sketch. So we need to create some distance away with this sketch, looking at the position and looking along the x-axis. 17 millimeters. So we've got that there. The reason why I didn't use that in this sketch, say offsetting it from here 17 millimeters, is because the center of rotation for this sketch will still be in here this way. If we did it via the sketch, then we're offsetting from this vertical axis this way, and when we rotate, the center of rotation will be back here, so in line with the axis cross. So our rotation will be awkward to get right. Now we've got these, we can start adding our arcs. So I'm going to create a new sketch for the arc that goes this way. And we're going to pull these in as tangent constraints. So all we're doing is creating this arc here, not this section or this section, because those are being created with our other sketches. And then creating tangency with this arc as a projected line. So when we use the import geometry, we import that arc in. So looking from the front, we create a new sketch along the XZ plane, and OK. It's placed us in the center of our scene. So in the center of this line here, which is fine because we just changed this via offset or attachment. I'm going to pull in these arcs and they will create a planar geometry along that line. So using the external geometry tool, pull in both these arcs. Now what we can do is create an endpoint and endpoint arc. Remember, we've got the auto constraints on, and we'll hover over that point to make coincident constraint, hover over this point to make coincident constraint, and create our arc. So we've got this arc in here. We want tangency across these lines. So I take this line and make a tangent constraint. We've got a removal of constraint. If I hit OK, you can see we've got a solver failed to converge. And that's because we have an attachment across 2 straight lines. We can't create that tangency in there just yet. So I'm just going to Control Z that, or we can delete that constraint. Let's make sure that this is still connected, which it looks like it is. So what I'm going to do is just change this line here and have this angled upwards. To do that, we need to angle these arcs. And this is where we're angling this at 45 degrees, but we're going to take it slowly so we can see what happens. Let's close that. Let's click on this sketch. And at the moment, if I come down to the attachment and down to the angle, and let's put this, say, at 10 degrees, you can see it's rotating along the wrong axis. We need to change the axis. So we look at the axis, we got a 1 at the moment in the Z, so a positive 1, so it's rotating around the Z axis in a positive manner. So the Z axis runs normal to sketch this way. So we need to place this 1 in the Y and a 0 in the Z. So we look at that now. we can see it's rotated down this way. Let's change that. Now we can either do minus on the Y, but I'm going to use the angle. So we have the angle there because these two will be the same angle, but one will be positive and one will be negative. So the axis, we need a 1 in the Y and a 0 in the Z. Notice the arc changed. The arc changed position. Let's come into that arc. So this one here, double click it. You see it's still connected. Now we've got some angle on this. We can apply the tangency and the tangency here as well, like so. Closing that. That's now tangent if we look from the front with this line. So these arcs here, we just need to offset this. So I can use an attachment, or I could just use the attachment offset by coming into the position, looking along the Y axis, and we'll move that. You can see it's not moving correctly at the moment because what we've done is use the Y axis of the sketch. This is the local coordinate system. Moving it along the Y didn't work because we sketched upon this plane. So Z runs this way in the local coordinate system. So we come into that sketch. You can see that the X is here and the green is the Y, which we moved this along. So we've got to move this along the Z. Let's just control Z that a minute. You can see also it's broken the sketch. So that's zero that out. Click off, that's back to normal. And take that and move it along the Z. So we can move this 13 millimeters this way. That's now in position. And I'm going to take that sketch and duplicate the selected item or the selected object. We don't need all of these, we just need sketch 002, so uncheck them all until we get sketch 002. That's just got the grey square on. So that's selected. Okay, that. We have this one now. At the moment it's at 13 and we can do minus 13 to place it over the other side. Now we've got this curvature between these. If I come into the sketch, say this one here, and change the angle to 45 degrees, and do the same for the other one, minus 45 degrees, we can see the sketches have failed. So let's come into that sketch and have a look what's happened. Let's delete one of the tangencies, and you can see we have that arc there. So what I'm going to do is take this point and this point, coincident. The reason why this is not working is because of the angle and the length of those imported geometry. If we create an arc all the way through there, you'll notice that the arc will actually extend down below the line. So because we can't have tangency across both these lines, one way around this is to actually create two arcs. So I'm going to delete this arc and create another arc. And also another one. Those at the moment are coincident with each other. And then we're going to use this line and this arc with tangency, this arc and this arc with tangency, and then this arc and this line with tangency as well. Therefore we have tangency all the way across there, and we could decide basically where the split is. When we do the sweep, this will create two parts to this sweep along this edge. For the time being, we're just going to go with the standard single arc that connects up, coincident and tangency. So let's close that and do the same on the other side. So we've got exclamation mark on there and it's saying solving the sketch failed. Let's double click that and delete this tangency. and take this point and make them coincident. So that's fully constrained now. Let's close that and see what we have. So we now have the shape that we need for the sweep. So we have all the sizes in here. We've got 17 millimeters away from these 2 points. Radiuses of 3 millimeters, 20 millimeters length. And now we just need to use the profile along here. So this is just going to be a circle profile. You can see we've got a 3 millimeter length on this one. So this one, I believe, is 2 millimeters. And also we need to deal with this gap in here. I'm going to show you quite an easy way where we can pad part of that sweep. So let's add the profile. First of all, I'm going to rename these as the path. So path 1, path 2, path 3. So now I've renamed all 4 paths. Let's create the profile. We're going to do that with a new sketch, and we're going to go along the XZ plane because the profile needs to sit here. So we're going to use a sweep profile. This is the cross section of this piece, which is constant all the way around. XZ plane, and it's basically a circle. So come in, create the circle attached to the center point, and set the diameter of this to 2 millimeters. This is our path we want to sweep around, but we're going to hit a problem. Let's quickly rename that to profile. Now create our sweep, which is known as an additive pipe. This one here. First select the profile, and we can select it from the additive feature and additive pipe. The profile has been pulled in, and now we can add the edge, but we're going to hit a problem. Let's hit add edge and select our first edge. We can see that's come in. Add edge, and next edge, it's been pulled in. Add edge again, this edge. So this is all one sketch, this part here. Now we get onto our second sketch, these lines here. If we look at path to sweep, it's only got one object in here, path 1. So if I add the edge of this one, we get a problem. It doesn't actually add it in because it's only wanting one object. How do we get around that? Let's cancel that and think about what we need to do. We need to connect up all of these lines and all of these curves. To do that, there is a tool called the subshape binder, which binds shapes into one across multiple geometry or multiple edges, etc. So I'm going to select all of these, path 1, path 2, 3 and 4, to make one single path. Also available on create a subshape binder or create a sub-object shape binder. You'll see a binder has appeared. If I keep these selected and just press the space bar, that hides them all. And though we've hidden them, we can see we've still got the binder left, which is a single object. Now when I click the profile and use the additive sweep, the profile goes in, add edge, and we can add the edges to this from a single object. Better still, let's click the object and select the object. And the whole lot has swept. Let's hit OK. And now we have our sweep. We've come to the part of the project where we need to create this feature here. So this is just an extension out of what we've already done with the additive pipe and then this disc. We can see that we've got a 2 millimeter length to add plus a 3 millimeter diameter of disc, which is 1 millimeter in length. We don't have to add a sketch for this. This can be done with a standard pad. So if we look at our model, we can see that this face here, if we click on the top, it's all on one plane. So we draw a line here, it's all on one plane. That means when I click on the pad, this will pad forwards, and we can set that to 2 millimeters. And click off, and that's padded forwards. Let's OK that. And now we have the pad. We can do exactly the same on the other side as well. But what we're going to do is just finish this side first. I'm going to create a sketch on this face. Create a new sketch. It's placed me right in the center of there. So we're actually on that face, the same line as that face. We just need to do a section view for the sketch. View section. And now I can create my circle on here by pulling in some external geometry and creating the circle. So a circle attached to here and circle out. And with this, we come over to the diameter and set this to 3. Let's close that. And now with that sketch selected, we can pad by 1 millimeter. And we've created that feature there. We can repeat that on this side, or we can use a mirror. Remember, I didn't use symmetry across here. No, we could, but it was easy enough to sketch that anyway. And also going through the process a couple of times just concretes that knowledge in. As this is symmetrical, bring back the axis cross, we can just use these two features. So the pad, control click the next pad. So those two there, those are the last operations that we did. And then use the mirror. If we look, we want to mirror over the XZ plane. So at the moment it's base XY. We zoom out, can't really see where that's gone. So let's go base XZ, and we can see that feature has come across. And hit OK. We have now completed that part, and we're ready to move on to assembling these in an assembly workbench. And that will be in our next video. So I hope you enjoyed that, and I look forward to seeing you in our assembly video, part 5. If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a coffee site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. Any money that's kindly donated will be used to expand the channel. Thanks a lot for watching and subscribing, and I'll see you again soon.